Okay, we've got here a 67 Pro Reverb that I last serviced 5 of 18. So I did a full recap. All these parts were changed out on the board. I'm sure I took the entire thing apart as I do and cleaned it and rebuilt it. This one belongs to the same studio as that 64 Deluxe yesterday, and the same complaint that it's blowing fuses. It's got a pair of Tungsol 6L6 GC SDRs, which are one of the better 6L6s on the market today. It's got a old GE GZ34 rectifier. And I'm going to start by pulling the rectifier tube and the output tubes. Give them a listen. Look for an obvious discoloration, because those are the most likely causes of a blown fuse in a Fender. In yesterday's 64 Deluxe, it was one of the two 6v6s. That doesn't mean that that'll be the problem here, but it's a good place to start. And there was to me, a curious comment on that 64 Deluxe video yesterday, where a guy said he wanted to vent because techs, including myself, don't just start going to a tube tester before anything else is done. And he thought that was curious and why. And from my perspective, everything I showed in that video yesterday was tube testing, very careful tube testing. I didn't use a tube tester because the ones I have are old and I need to reservice them at some point, and I've not had the time. And they don't test at the full voltage. They test like 200 volts or so. Most tube testers test at relatively low voltages. You know, I find that an actual working amp is the best tube tester as long as you're taking precautions so as not to cause damage. Now, the inside of this amp, as you can see, has got a lot of dirt and oxidization on the chassis. And you can see when I redid the grounds, was that now 4 years ago, I made very nice clean spots on the chassis where I could put those grounds. I'm going to do a visual inspection, and I'm going to make sure that the resistors are all connected here at the output tubes and they all look good. And then I'll go through the preamp board and I'm going to check these heater balance resistors. And once I'm sure that I don't see anything that's definitely off, and I don't measure anything that's definitely off, then I'll power it on without tubes. We'll check the heaters like we did yesterday. Then we'll introduce the rectifier tube and test that, and then we'll introduce the power tubes, testing the heater function first, and if all is well there, then we will proceed to actually powering them on and see how they bias. Let's see. It says it's blowing fuses. It has a blown 2 amp fuse, and it takes a 2 amp fuse according to the schematic. Side note on that, sometimes that 2 amp fuse rating from the 60s and 70s amps is a little bit on the underpowered side in use with modern wall voltages. So sometimes you want to go up to a 2.5 or 3 amp fuse there. Sometimes, and you should only really do that if you're a tech, or you have a good tech who said, yeah, absolutely. We are going to certainly start this with a brand new 2 amp fuse. And if we have a problem just powering it on with 2 amps, then there's a serious problem. What I mean by sometimes you want to go to a 2.5 or 3 amp fuse is if it's fine most of the time, but when you play really hard and loud, sometimes with modern wall voltages, that's not your friend. So I'm going to start by measuring the heater balance resistors. They're 100 ohms each, and each one should measure about 50. They're each measuring 51.5. That's good. Again, I've got the original resistor and diode on the bias supply. In the past 2 years, I've started replacing those on every amp that comes in, just because I've had those old diodes fail. So that 470 measures 550. Let me check the diode. 0.6. Overload, that's good. All right, I've got some 3-watt screen grid resistors on this one. I usually use a wire wound on these now, but these metal film 3-watts should be good. Yeah, they're both measuring good. 474 on each. And this grid stopper. .42. Having a hard time measuring that one. Do I just have some dirt? From the looks of those, I replaced those 4 years ago. .48. Okay. Let me go through here and do a visual inspection of stuff on the board and take a few more measurements. If I find anything there, I'll show it. Otherwise, we're going to move on to powering it up without any output tubes or rectifier installed. Okay, I see one thing that could be the problem, or could be a problem. This solder joint right here doesn't look so great to the eye. To the eye, it looks like this 220K resistor is beginning to pull out of that solder joint. That can happen as the board flexes over time. And that is a grid leak, which is also a bias leak. So if that resistor is intermittently making a connection there, then the tube on that side, which would be this first power tube, would intermittently have and lose bias reference. I'm not saying that's definitely what's happened here, but it's possible. Now this is the factory solder joint. So I'm adding fresh solder to get some flux on there. And I'm going to get it all the solder right back out of there. And the reason is because that lead of that resistor looks like it was pulling out and kind of floating in the solder joint. And especially given how corroded the chassis is in that area, the lead is tarnished. And sometimes a tarnished lead that's broken off inside a solder joint gets corrosion down in the solder joint. And it can make it difficult to get a good clean connection again. So, hello, I'm doing a video. So I want to get that old stuff out. And where's my stuff? And I want to make sure this lead is cleaned. So I'm going to re-tin that a little bit because the flux in this fresh solder actually cleans that metal pretty well. That's one of its primary jobs. I'm going to snip off a little bit of the end that was making it want to sit up a little bit in the joint. Let's see if I can do this without moving the camera. Okay, I've got the lead from the cap. I've got the lead from the wire going to the grid. And those are both physically blocking that resistor from sitting in the eyelet well. So get my dental pick, heat them up, and move them to the side a little bit. Now this resistor should go in that eyelet much better. loosen the screw right here. Pull the board up a bit so I can get the resistor down without pushing that wire lead out of the way. It's not wanting to fully cooperate. It's bent just a little too far. Remove those other leads again. Okay, I'm not sure how much of this will be really visible from your angle because I just set it so you could see that spot, and I needed to be the one to really see it. Reflow a bit. Just get a solder fillet in there to make sure everything's good. Press down on the resistor so it doesn't flex as the solder cools. Retighten that screw. Pause this and give it a dome. Okay, it's got a dome and its neighbor here, its partner on the other side of the output. I removed the top layer of solder just to make sure it was good, and I gave it some fresh. Those are just very critical solder joints. Almost anything else in the amp can come desoldered aside from grounds, and you just lose output. If the bias connection were to go bad, you lose tubes, potentially transformers. Now I'm looking at this thing, and one of the things I see is that a long time ago, before I had a shot at this amp, the heater secondaries from the power transformer were spliced. And so that's a point of possible concern as to blowing fuses. But I'm going to power the amp on and see how the heaters are doing and check my current meter as I do that. If we have a short in this condition without a rectifier tube and without power tubes in place, that will tell us that these spliced heater wires are a source of concern, or there is some other source of concern. Worst case scenario, we've got a bad power transformer. That doesn't happen very often, but it can happen. Let's power it on and see what we see. All right, so the current light limiter is not doing anything. That's good. And the light bulb is nice and bright. And unloaded heater supply in this amp is, well, aside from the preamp tubes, which really don't draw much current, 6.6 volts AC. That will certainly drop down when we add the output tubes. So we power it off, and we'll put this old GE rectifier in and see what we see. All right, so we're going to power it on with the amp in standby. Let that rectifier tube heat up. And I'm watching the current meter, and I'm watching the rectifier tube. Sometimes these will do little light shows. Sometimes they do it just from having power and actually rectifying, and sometimes they do it only when there's a current draw through them. So you won't have a rectifier failure until there's current drawn through the output tubes. While that's doing that, I'm going to take some measurements. Just let that warm up. And my secondaries on the AC side are 723 and 5. That's good. And the unloaded B plus of this amp in standby is 499, 498. That's why they have the series caps on the first stage. But all that is good. So let's power it off. And we'll put these power tubes in. Now, these power tubes are the most likely cause of a short in a Fender. As I said, they don't rattle, and there's no discoloration as if they've gotten too hot. But then again, neither did those bad EH6v6s in the 64 Deluxe yesterday. So there's just no earthly way of knowing which direction we are going. And the river keeps on flowing, and the gates of hell are glowing. All right, let's power this on. Again, in standby with a current limiter. And let me confirm that my volumes are off, tremolo's off, reverb's off. Letting that warm up a bit, let me hook up a speaker cable. To a degree, and even to a pretty good degree, the Fender output jack being grounded out right there, if nothing's plugged in, can protect the amp from a lot of stuff, but I do prefer to give it a load whenever possible. And think of the ground as just the world's best load, but also like to hear issues. So if there's a hum in the output that should not be there, I like to hear it. All right, so it's been on a while in standby and no current weirdnesses. Let's take it out of standby. All right, my light bulb limiter is beginning to glow, but at a normal amount. So all that seems okay initially. I'll keep an eye and an ear on that while I measure some voltages on the output tubes. And then if everything seems okay, we will check the bias, which is what revealed the problem on that Deluxe yesterday. So 42.8, that's negative on the grid. Negative 42.8. Screens are 404 and 404. Plates 4028. 403. 403, yeah, that's not a variance, that was just fluctuation. Okay, so far so good. I'm going to jiggle the wires going to each tube. All the connections seem good. So let me power it off and let me measure the bias. Let me also flip the standby switch a few more times. It's got a noise that shouldn't be there. Sometimes standby switches can arc in Fenders. It's a switch designed for switching AC. And when I do that, there's a flicker of the pilot light. I think that may be arcing. Anyway, those switches were designed for a large value AC, never to be designed. They were never designed to handle high DC voltage in the 400 volt range. That might be the source of the issue. But anyway, let me take some measurements and see what the bias is at. Okay, with the current limiter off, this thing now has a loaded B plus of 470 volts. And the tubes are biased at 57.7% idle and 59% idle, which is pretty much in the ideal range. Those are very closely matched. There's no microphonics. I don't know that I'm going to have a problem with this amp at this point. It might have been that solder joint that just didn't look right to me, if that was vibrating, connected and disconnected. But given how critical a bias failure can be, I didn't want to take the risk of damaging tubes or a transformer rather than blowing the fuse. It could also be the standby switch, which makes way too much noise when it comes out of standby. Though I'm not getting as much of a surge in the pilot lamp now that the current limiter is off. Let's see, fully loaded heater supply now is at 6.5. That's good. That's within the realm of the desirable. Let me move the camera down a bit and we'll see what it sounds like. And if this thing is blowing fuses at this point, it may only do that at high volumes. But let's see. Let's just give it a general health check. I'll start with the normal channel. A little bit of scratchiness on the bass pot. I don't think this channel is used as often as the other. A little bit of scratchiness on the bright cap too, the bright switch. Albeit with the brief playing test, that all seems very healthy. Let's try the Vibrato Channel. A little bit of scratch on its bass pot too. That all sounds quite good. That's through my test cab. Let me get its actual cab, just to make sure that there's not a problem with its speaker wiring. I installed some new speakers in that cab 4 years ago, but it still has the original speaker wire and harness. Sometimes those will develop problems. And it's also possible that it's going to have a problem at its stock 4 ohm load that doesn't exhibit with the 8 ohm load that this test cab gives. So let me get that set up. Well, it's certainly a bit louder through the 4 ohm 2x12 than it was through my test 8 ohm 2x12. So if it's going to blow fuses, it's going to want to do it now. Sounds very healthy. That's with the volume at 4, and that is very much a fairly large stage volume these days, or most any days, unless you're playing the Garden back in the 70s. Had the treble up too high. Let me hook up a reverb tank and I get a dummy plug for the tremolo vibrato and check those as well while it's here. Okay, I turned the reverb down to a more manageable 3. Just not that huge a space. I guess this space is about 15 by 10 with about 10-foot ceiling, so it's a pretty good sized room, but It's a lot of amp to have in a room that size, and the Pro Reverb on 4 just puts a lot, I can feel the SPL. Anyway, let's try the reverb. Sounds pretty good. It's not as big as some, but this is a Mojo tone tank, not an old Accutronics or Gibbs. Let's see how the tremolo do. Well, that all sounds quite good. I'm not sure whether I should just flip the standby switch a few times and see if it blows fuses. Very minor microphonics out of the second power tube. Extraordinarily minor, though. Just barely heard. I need to call the owner and see if there were certain playing conditions that were happening. It's also very possible, as I mentioned, that I fixed it at the very beginning of this process. But that's the kind of thing that I don't want to take chances with, like I said. I'd rather have fixed it before I even tested it when the possible failure mode is buying the guy a new amp, because I didn't do it right on my end.